Let me ask you a seemingly simple question. I have a picture of fire here, and my question is, what is fire? Well, what would you say if I were to tell you that fire, as we see it, these flickering flames, it is nothing but hot air? And I know what you might be thinking. Hot air? I've seen air that's hot, or I experienced air that's hot, and I don't oftentimes even see the air. But here I clearly see something bright, something that's emitting light, something that's emitting electromagnetic radiation. And then what I would say to you, if you were thinking that, is it actually turns out that anything in our universe that has a temperature above absolute zero, 0 Kelvin, which is pretty much anything that you will ever come across in your life, emits electromagnetic radiation. Objects with temperature aren't the only way to create electromagnetic radiation, but it is a major way that's happening all around us. Even if you were in a pitch black room, you would be emitting electromagnetic radiation. A tree outside, even if it was dark outside, is emitting electromagnetic radiation. You might say, wait, but I don't see the tree, and that's because your eyes can only detect certain frequencies of electromagnetic radiation. If we look at this diagram right over here, we can see how we've categorized many of the frequencies. And you can see that up here, this is the frequency, this is the wavelength, and these are in powers of 10. So you can really view this as a logarithmic scale. And just over here, you can see that our eyes can only visibly see a small section of this logarithmic scale of frequencies. One of the things I like to wonder is if humans didn't have eyes, if we weren't able to detect even the small segment of the electromagnetic spectrum, would we even know that something like electromagnetic waves existed? But we could see you have gamma rays, X-rays, UV rays, infrared rays, microwave, FM, AM radio waves, long radio waves. And most hot air, the frequency isn't high enough for us to see it. So most hot air is going to be in the infrared range. Only if it gets hot enough will we start to see it. And that's what's happening with this fire here. And if you look closely at a fire, you might actually see that the location where the combustion reaction is happening, that actually might be dark. And then right above that, you'll see some blue flame. And then you'll see, maybe if you look closely, some green or yellow flame. And then you will see the orange flame. And then you will see the red flame. And the reason why it might be dark right where the combustion reaction is happening is that might be very high energy electromagnetic waves. That would be in the UV spectrum. That would be at a higher frequency than what's visible. So to our eyes, it looks dark. And then as it cools, it goes through the visible spectrum. And then if it cools enough, it goes to infrared. But we human beings have built the capability to see beyond what our regular eyes can see. For example, these are what are often known as thermal images, but they're really just detecting the infrared range. So this is a picture of two dogs. It could be pitch black outside. I mean, it could be the middle of the night, but because they have temperature, they are releasing electromagnetic waves, which we can detect. And this over here has a scale of what the temperature must be. So you can see the eyes of the dog are the hottest part right over here. You can also see thermal imaging of not only a hand, but after a hand has touched a wall. With our eyes, if you were to touch a wall for, say, 30 seconds, it doesn't look like the wall has changed at all. But if you were to look at the infrared, you would see that you would have heated up parts of the wall and you would be able to see the shape of a hand. And so you can imagine we human beings, because of our ability to detect electromagnetic waves and explore electromagnetic waves, we've been able to leverage them more and more in our everyday lives. Thermal imaging itself has a lot of applications. Firefighters use it to find people or to find flames in the middle of a lot of smoke. We have things like X-rays, which are high energy electromagnetic waves, which we can use to see through soft tissues. So we can see bones. This is an old image and it looks like they're using the X-rays kind of carelessly. You don't want to be throwing that radiation around. But even today, I got an X-ray of my teeth just the other day when I went to the dentist. When you talk on your cell phone, the way that your cell phone is able to communicate is leveraging electromagnetic waves. This is another thing that's mind-blowing to me, is that my little cell phone can actually emit electromagnetic waves in the radio part of the spectrum far enough to be received by a cell tower that could be 10, 20, and in certain cases 30 or 40 miles away. Microwave ovens literally release microwaves, which are absorbed by our food, which heats up the food. And so I'll leave you there. The big picture here is that electromagnetic waves are all around us. It's most obvious to us in the visible spectrum, because that's what we can see, but there's a large continuum of different frequencies that the visible is only a part of. And we human beings have leveraged this phenomenon in all sorts of interesting ways, and I would suspect that we're just at the beginning of this exploration. Maybe you will come up with a new application of electromagnetic waves.